Hello guys, welcome back to another video. As we told, we are back with another video of prerequisite, which is on calculus. This is Mehul,
Hello, this is Pratyay.
and today's topic that we are going to start with is differentiation.
Yes. So in this figure, as you can see, the x and y axis are drawn, and a line is shown passing through both the axes. And we will take this line to be a function of x as f of x, as we call it in mathematics. A function of x is represented as f of x. So this function is a straight line that is passing through both the axes, and the slope of this line, as we have learned in high school physics, is definitely the y by x, that is rise by run. Now y by x, that is the slope, but uh, the to find out the derivative of this function, we use this slope in a very efficient manner. Now, for a small change in x, which is represented as dx in the figure, and a small change in y, which is represented as dy in the figure, there is the length of the line becomes smaller, as in this small triangle, uh, which small right angle triangle, which has the slope of dy by dx. And so the derivative of this function is dy by dx, which is the slope for y and x whose values are becoming closer to 0. And as the values of y and x are coming to 0, the derivative is getting more accurate. The derivative is indeed the true slope of the function. So the derivative can be written as the limit of the change in y divided by the change in x, as the change in x goes to 0. That is, the change in x becomes increasingly small. In this case, we notice that the slope would be y by x, as it is always, but it is special in this case because it is a right angle triangle with one angle as 30 degree, and the as y by x can be written as tan of 30 degree, because here y is the perpendicular and x is the base, and tan theta for all theta is equal to perpendicular by base. So tan 30 is equal to y by x. Now we know tan 30 degree is equal to 1 over root 3. So here dy by dx is equal to, or the slope is equal to 1 over root 3. Okay, so now we move on to some formulas. Um, so first of all, dy by dx can also be written as y prime, because both of them mean the same thing, which is the derivative of the function y in x. Now, the first formula is d, dk by dx, where k is a constant, is equal to 0. Because if you think about it, then a constant function varies irrespective of x, and therefore there is the change in x and the change in the function with x is 0. So next is dx by dx is equal to 1. So here the function is x itself, and this is fairly intuitive as x will change with x in the same rate. So the derivative will be 1. So the next is d kx by dx is equal to k. Here the function is kx, which is a constant multiplied with x. So the rate of change will also be the uh, change in the kx with x. So it will be kx by x, which is equal to k. And this is fairly intuitive for me.
Next, we come to the addition formula, which is d by dx of f of x, which is one function, plus g of x, which is another function, is d by dx of the function f of x plus d by dx of g of x. Okay, next is the subtraction similarly, which is d by dx of two functions f of x minus g of x, which equals d by dx f of x minus d by dx g of x. Next, we come to the product rule, which says that d by dx of f of x into g of x is d by dx f of x into gx plus f of x into d by dx of g of x. This is known as the product rule. Product rule. Here, the differentiation on multiplying two functions, we get the differentiation of the first function into the second function plus the function which was previously differentiated is now not differentiated into the function which was previously not differentiated. So this is the final result which I told. Next, we come to the quotient rule, which is d by dx of f of x divided by g of x. This is d by dx f of x into g of x minus f of x into d by dx of g of x. The whole is divided by g of x, this function's whole square. So this is the quotient rule. These two are important for in differentiation, the product rule and the quotient rule. Next, we come to another identity which tells that d by dx of f of x is nx to the power n minus 1 if this is only possible if f of x is equal to x to the power n. Now, there are some important results of differentiation of trigonometric functions, which I'm going to tell now. The first one will be d by dx of sine x is equal to cos x. D by dx of tan x is equal to sec square x. D by dx of sine square x is equal to sine 2x. D by dx of cos x equal to minus sine x. We have another one, which is d by dx minus cot x equal to cosec square x. Another one is d by dx of sec x equal to sec x into tan x. And the last one, d by dx of minus cosec x is equal to cosec x into cot x. So these are the basics for differentiation. We are going to give all the proofs and all the necessary things, the full course on differentiation on our channel Mathematics for the Olympiads. For now, just try to remember this for some for questions in physics. Next, we will move on to integration. Okay, so now we move on to integration. So what is integration? Why do we need it? So integration is mainly used to find the solution to two problems. The first one is the problem of finding a function whenever its derivative is given. And the second problem we face is that the problem of finding the area bounded by the graph of a function under certain conditions. So from these two problems, we derive integration. So integration are of two types, definite and indefinite. So indefinite means that we can find the value, any value of a variable, and definite means limiting it within certain ranges. Okay, so now let's jump into the basic integration for which we need for now. So the first one is, we will have to know that integration is the inverse process of differentiation. We know that d by dx sine x is equal to cos x. Okay, so in this one, we observe that the function cos x is the derived function of sine x. We say that sine x is an antiderivative or an integral of cos x. So sine x is an integral of cos x. So we can write this as d by dx sine x plus c is equal to cos x. We note that for any real number, c is treated as a constant function. Its derivative is 0, and hence we can write it like this. D by dx sine x plus c equals to cos x. Similarly, I'll give you another example. We know that d by dx x cube by 3 is x square. Here x cube by 3 is the integral of x square. We can write this as d by dx x cube by 3 plus c equals x squared. Now let's try to understand all these in terms of in notations of integration. We see that integration of f of x dx, this means integral of f with respect to x. F of x in this whole expression is the integrand. It is known as the integrand. X here in this expression is known as the variable of integration. Therefore, the one which I wrote here in this one, d by dx sine x equal to cos x. Let's now write this in the forms in the integration notation. It will be integration of cos x dx equals sine x plus c. Now let's move on to some properties of or identities of integration.
So there are mainly three formulas in integration. The first one is d by dx of integral f of x dx is equal to f of x. Or in other words, we can say the derivative of the integral of the function is the function itself. The second one is called integration by parts, in which, and in this formula we use u is equal to f of x and v is equal to g of x, and the formula is integral u dv is equal to uv minus integral v du. This is a very useful formula. And lastly we have another formula, that integral k f of x dx, where k is a constant. This is equal to k integral f of x dx. So we can just factor out the constant.
This can also be written as integral of f dash or the derivative of f of x dx, which is also written as f of x plus c, the constant which I told earlier, which we take as c. So we can conclude that integration is the inverse process of differentiation. So why is it? It is because instead of differentiating a function, we are given the derivative of a function and are asked to find its primitive, that is the original function. This is why integration is known as the inverse process of differentiation or anti-differentiation. Okay, so this is all for today. We'll be back soon with another video. Till then, stay safe and bye.
Bye bye.